Hello everyone. The title of this video is Determine whether an ordered triple is a solution of a system of three linear equations with three variables. Alright, so in this video we're going to see examples of systems of three linear equations with three variables. Now these three variables in every single one of these examples is going to be a x, y, and z. Alright, and an ordered triple, just like an ordered pair, but with three numbers. An ordered triple is made up of three numbers separated by commas, where the first coordinate is the x coordinate, the second coordinate is the y coordinate, and the third coordinate will be the z coordinate. Okay, so all the exercises I'm doing in this video are taken from a free online textbook through openstacks.org. That book is their Intermediate Algebra 2nd edition, and I'm in section 4.4 titled Solve Systems of Equations with Three Variables. Alright, so the exercises I'm going to be doing are 162 through 165. There's parts A and B for both of them, for all four of them. And you see in every single one of them we're given a system of equations. There are three equations, and throughout these three equations, three variables appear, x, y, and z. And what we're asked to determine is whether the given ordered triple, you see this example here, 3, 1, 3, determine whether this ordered triple is a solution of the system. And it's very similar to how we checked for solutions to systems with two equations and two variables. I just replace all the variables with their corresponding values and see if every equation is true. Right? The only way an ordered triple is a solution to the system is if every equation in that system is satisfied, is true. As soon as I find one equation that is false for that ordered triple, then we will say that that ordered triple is not a solution. Alright, so it can't just satisfy one or two of them, right? It's got to satisfy all of them in order to be considered a solution. Okay? Alright, so first example, this is exercise 162. Right, I'm just calling it example 1. And if you want to follow along, right, example 1 is exercise 162. Example 4 is exercise 165. And I do have time stamps for each of the examples in the description of the video below. And one more thing to point out that I would like you to do, as a student, when I bring an example up, pause the video and try working on it yourself first, and then watch me do it, and compare your work with my work and see where you made mistakes or where you can improve, or just to see how you did. Right? See where you're at. Alright, so in example 1, got these three equations with three variables, x, y, and z. 2x minus 6y plus z equals 3. 3x minus 4y minus 3z equals 2. 2x plus 3y minus 2z equals 3. And again, we're asked to determine whether the given ordered triple is a solution to the system. Alright, so ordered triple. Right, and it comes in a specific order, right? The first, as I mentioned, the first coordinate is the x value. The second coordinate, which is 1 here in part A, that's the y coordinate or the y value. and the third coordinate is the z value, right? And it's always going to be in that order. They're typically in alphabetical order. We're using X, Y, and Z in this video. In other examples you might come across, the letters could be different, right? It doesn't always have to be X, Y, and Z, but it will be for this video. Alright, so just because there are so many equations here, I'm going to label them. Alright, so I'll just say E1 for equation 1, the top equation, E2 for equation 2, and E3 for equation 3. Alright, just to give us some labelings. Alright, so part A, is the ordered triple 3, 1, 3 a solution of the system? Right, again, does it make all the equations true? So we check. So first I go into equation 1, right, so E1. Go through and replace x with 3, y with 1, and z with 3, and see if we get a true statement. So that's 2 times x, right, 2 times 3, minus 6 times y, or 6 times 1, plus z, which is just plus 3. And is this equal to 3? Alright, well, simplifying the left side, I'd have 6 minus 6, which is 0, plus 3 is 3. 3 equals 3. True, right? Great. Again, so far so good. Right? This ordered triple makes the first equation true, but that doesn't mean it's a solution of the system. Right? Again, it has to make all three of them true to be a solution of the system. And if I find just one equation that is false, then it's not a solution. Alright, equation 2. So we have 3 times the x, which is 3 times 3, minus 4 times the y coordinate, which is 1, minus 3 times the z coordinate, which is 3. And is this equal to 2? Alright, so simplifying the left side, we have 9 minus 4 is 5, and then minus 9 again. Alright, so 9 minus 4, that's 5, minus 9. 5 minus 9 is negative 4. So I have negative 4 equals 2 when I'm done simplifying both sides. This is clearly a false statement. I'll put a big X next to that. Now, because I have found an equation that is made false by our ordered triple, I can stop. I don't need to check the third equation. Alright, so because this second equation is made false by that ordered triple, I would say then that the ordered triple, right, 3, 1, 3, pardon me, is not a solution of the system. Right. Sure, it's a solution of the first equation, right, but not all three. So not of the system. Alright, so let's look at part B. So we're given the ordered triple 4, 3, 7. Right, 4 for x, 3 for y, 7 for z. And I gotta start over. Right, equation 1. Check them all. So 2 times the x, right, 2 times 4, minus 6 times the y, right, minus 6 times 3, and then plus the z, right, plus 7. Is this equal to 3? Well, this is 8, right? And then 8 minus 18 is, negative 10, plus 7 would be negative 3. And right away, I'm seeing that this is not a solution. because we have a false statement right from the get-go. Right. Again, 8 minus 18 is negative 10, plus 7 is negative 3, not positive 3. And I can stop now. Alright, this is a false statement, so that means this ordered triple 437 is not a solution of the system. Alright. Okay, and there's the first example. Now be careful though. Just because these two order triples didn't work doesn't mean that the system doesn't have a solution. Alright, the system may still have a solution. Right? There may be a value of x, y, and z that satisfies all three equations. It's just not these two. That's all. Right. Okay. So yeah, so don't just don't just say, oh, this must have no solution because these two don't work. Right? There are still infinitely many points out there that could triples out there that could possibly work. So we'd have to go through and we'll see in a future video how I would go about solving a system like this through elimination. But for right now, we're just checking ordered triples. We're checking for solutions. All right, example 2, which is exercise 163. Same thing. I'm given 3 equations. And in this system of equations are 3 variables, x, y, and z. And I'm given 2 ordered triples to check, is this a solution of this system? All right, so again, I'm going to call the top equation E1 for equation 1, E2, and E3. All right, equation 1, 2, and 3. Alright, first ordered triple we're given is negative 5 for x, negative 7 for y, 4 for z. Alright, so let's go into E1, equation 1. Top equation. So we have negative 3 times the x coordinate, right, times negative 5, plus the y coordinate, negative 7, plus the z coordinate, is just 4, and is this equal to negative 4? Let's see. This is 15 plus negative 7 would be positive 8 plus 4 would be 12. So immediately I am getting a false statement. I'll write that and put a little big X next to it. And again, because we found a false statement right away, I don't have to check equations 2 and 3. All right. So this ordered pair, right, or sorry, ordered triple, negative 5, negative 7, 4, is not a solution of the system. Okay. Easy enough. Alright, so let's move on to part B. 5, 7, 4. Again, make sure you got it in the correct order. Alright, 5 for the x's, 7 for the y's, 4 for the z's. Alright, so let's go into equation 1, E1. Take negative 3 times the x coordinate, right, negative 3 times 5, plus the y coordinate, which is 7, plus the z coordinate, which is 4, and is that equal to negative 4? Let's see. That's negative 15, plus 7 is negative 8, plus 4 is negative 4. We do get negative 4 equals negative 4, which is true. So since that first, this ordered triple, it's a solution to the first equation. But that, again, that doesn't mean it's a solution to the system. We have to check all the equations. So now I can move on, though. I can actually move on to equation 2. We have negative x, right? So that's negative 5, the opposite of the x coordinate, plus 2 times the y coordinate. Here we're given that as 7. Minus 2 times the z coordinate, right? Minus 2 times 4. Is that equal to 1? Well, let's see. This is negative 5 plus 14. That'd be 9. Minus 8 is indeed 1. Get 1 on the left, 1 on the right. Another true statement. So this ordered triple, it's a solution of the first equation, it's a solution of the second equation. But again, that doesn't mean it's a solution of the system. I have to make sure that it's a solution to all the equations. And now finally we have to check equation 3. So that's 2 times the x, right? 2 times 5, minus the y coordinate, right? Minus 7, minus the z coordinate, right? So minus 4. And is this equal to negative 1? Let's see, this is 10, minus 7 is 3, minus 4 is negative 1. So I get negative 1 equals negative 1, a true statement. So this ordered triple, 5, 7, 4, does satisfy every equation in the system. So this leads me to this statement, right? This ordered triple, 5, 7, 4, is a solution. It is a solution of the system. Satisfies all the equations. Great. Now that doesn't mean it's the only solution. Right? There may be other solutions, but we have just found one. Right? Like I said, in a future video, a video after this, we'll talk about actually finding how to find the solutions to a system with three equations and 3 variables like this. Right. Okay, example 3, and this is exercise 164, I believe. Same thing, and we're given 3 equations in a system, and among these 3 equations appear 3 variables, x, y's, and z's. Now again, not every equation has all 3 variables. Like, the first equation has just y and z, the second equation has just x and y, the third equation has just x and z, but still the system as a whole includes 3 variables. Right, so it's 3 equations, 3 variable system, just like the first 2. And just like the first 2 problems, first 2 examples, I'm asked to check, is this ordered triple, 7 for x, 12 for y, and 2 for z, is it a solution of this system? So as in the previous 2 examples, I'm going to call these equation 1, equation 2, and equation 3, right? E1, E2, E3. And let's go into equation 1. Right? So in equation 1, we have the y coordinate, right? So 12, and just pay attention, right? Pay close attention to what variable you're replacing and what value that would be. Again, this is x, y, z here, right? Ordered triple. Pay attention. So the y coordinate, 12, minus 10 times the z coordinate, which is 2. And is this equal to negative 8? Well, this is 12 minus 20, which is negative 8. All right, we get negative 8 equals negative 8, a true statement. So far so good. Right? This ordered triple is a solution of equation 1. Let's see if it's a solution of equation 2. equation 2, you're taking 2 times the x coordinate, right? So 2 times 7 minus the y coordinate, right? So minus 12, and saying, is that equal to positive 2? Well, yes it is, right? 14 minus 12 is indeed 2. Alright, so far so good still. Alright, this ordered triple is a solution of equation 1 and equation 2, but in order to be a solution of the system, it has to also be a solution of equation 3. Alright, so check equation 3. Take the x coordinate, which is just 7, minus 5 times the z coordinate, right? So minus 5 times 2. And is this equal to, positive 3? Well, left side, got 7 minus 10. Well, 7 minus 10 is negative 3. And negative 3 is not equal to positive 3. So that is a false statement. All right, so false statement. And that means that this ordered triple, right, 7, 12, 2, is not a solution of this system. Okay? Yeah, it's got to satisfy all of them, not just 2 of them. Alright, same thing for the next part, right? Part B, we're given the ordered triple, 2 for x, 2 for y, 1 for z. And let's go into equation 1. Take the y coordinate, 2, minus 10 times the z coordinate. Right, so minus 10 times 1. And is this equal to negative 8? Yes, it is. Right? 2 minus 10, that is negative 8. So again, starting off promisingly. Right. Equation 2. 2 times the x coordinate, right? So 2 times 2, minus the y coordinate, so minus 2 again. Is this equal to 2? Well, yeah, that's 4 minus 2, so, which is indeed 2. So again, I have an ordered triple that satisfies the first 2 equations, but it needs to satisfy the third one as well, right, to be a solution of the system. So let's see, take the x coordinate, 2, minus 5 times the z coordinate, which is 1, and is that equal to positive 3? And man, fails again, unfortunately. 2 minus 5 is negative 3, not positive 3. So this is wrong again, false again. So man, we were so close again, right? An ordered triple satisfied the first 2 up, but not the third one. Right, not the third one. So one more time, this ordered triple 2, 2, 1 is not a solution of the system. Right? It's a solution of the first 2 equations, sure, but not the third one. So it's not a solution of the whole system. Okay? Now, just as I said in example 1, just because these 2 don't work doesn't mean the system has no solutions at all. There are infinitely many ordered triples. So this could have a solution. But we don't know that, based on this page. And in a video, I've said this already, in a video after this, we'll talk about how to find the solutions of such a system. All right, and finally, same kind of example, example 4. This is the last one, which is corresponding to exercise 165. 3 equations with 3 variables showing up, x, y, and z. And again, I will label them equation 1, equation 2, and equation 3, E1, E2, and E3. Alright, so this first order triple, we have -6 for x, 5 for y, and 1/2 for z. Let's test it out. So first equation, x, right, so -6 plus 3 times the y coordinate, right, 3 times 5, minus the z coordinate, right, so -1/2. Is this equal to 15? Well, it can't be. You have 2 integers plus some non-integer is not going to be an integer. Right? So I can tell you right now this is going to be false, but let's put it together. -6 plus 15, that'd be 9, minus 1/2 would be 8.5, or 17/2. Is that equal to 15? No, 8.5 is not equal to 15. So I can stop right now. You know, this ordered triple is not even a solution of the first equation, so it definitely can't be a solution of the system. All right, so this ordered triple, -6, 5, 1/2, is not a solution of the system. Pretty easy stuff, I feel. All right, just plugging in and checking if you have all true statements or not. All right, part B, ordered triple we're given is 5 for x, 4/3 for y, and -3 for z. All right, so let's go into equation 1. We have the x coordinate, 5, plus 3 times the y coordinate, right, so 3 times 4/3, minus the z coordinate, which is -3. And is this equal to 15? Well, let's see, you have 5 plus, 3 times 4/3 is simply 4. 5 plus 4 is 9. And minus -3 is +3. So 5 plus 4 is 9, plus 3 is 12. And I have the statement 12 equals 15. Well, no, it doesn't. So a pretty easy last example here. Both ordered triples I was given didn't even satisfy the first equation. So both of these ordered triples, right? So this ordered triple, 5, 4/3, -3, yet again is not a solution of the system. All right, so in all those examples, right, all 4 examples, all 8 parts I did, all 8 ordered triples, only one of them ended up working. And that doesn't mean anything, okay? You just keep checking. You might come across more where they do work and stuff, but just as I said with example 1 and example 3, just because both of these don't work in this system doesn't mean that the system has no solution. All right, the system could still have solutions. It's just that these two are not one of them. All right. Are not among the solutions. Okay? Yeah, very simple stuff. Ordered triple, x value, y value, z value. Plug them in and see if all the equations in the system are made true or not. Right. And I hope watching me go over these examples here help you out when you're working on similar problems. And thank you very much for watching.